What's going on, guys? It's the Unhinged Engineer. I'm back today with episode 26 of my GT OMSCS vlog. So this is your first episode with us. Welcome. I'm getting my Master's of Science in Computer Science at night through Georgia Tech's online part-time program while I continue to work full-time as an aerospace engineer. And so I'm currently taking CS 6475, which is computational photography, kind of part of my larger perception robotics specialization I chose. And yeah, today I'm talking about the third assignment of that class, which is about panoramas, which is exactly what it sounds like. You're taking a few images of a scene at different angles and you're stitching them together into one continuous panoramic image. And so yeah, all the cool image processing and math that goes into that, no Photoshop for us this time, we're doing it in Python. And so yeah, I'm gonna talk about that assignment primarily. In addition to that, I'll briefly touch on project one, which I'm just starting to dip my toe into, as well as some of the other things going on in the class. But yeah, without further ado, let's talk about assignment 3. So what is the math that goes into stitching a panorama together, at least as far as this assignment is concerned? I would say there were two kind of main parts to it. One part was like feature detection and matching, which you use to kind of make sure that you're morphing the images together in a like reasonable, coherent way. And then the other side is like the warping and the stitching. So you actually take the two kind of canvases of images you're trying to merge, and you merge it correctly, right? And just for the record, I'm going to be discussing pairs of images because the algorithm that we came up with here, you kind of use in a chain. Like you do two, then you move on to the next two, and then you move on to the next two. So you don't take like however many images, n images, and put them all together at once. You kind of go from left to right. Much like if you've ever taken a panorama with your iPhone, you do the sweep and it stitches it together as it goes. Same exact thing. Well, probably way less sophisticated, but still. In any case, starting off with the feature detection and matching side, I would say this side was like honestly kind of more academic and something that is good to know and is a very large computer vision topic, but for the purposes of computational photography, we kind of just like used it to set up the larger conversation about the image warping and processing that we have to do, right? Because in case you didn't know, like CS 6475 is paired, I shouldn't say paired, and I also don't remember the number, but it's taught by the same person who also teaches computer vision. I think at one point they may even have been the same class, but I'm not certain about that. In any case, there's obviously a ton of overlap there, and it appears that maybe they focus more on the feature detection side with the computer vision stuff, and this side more on the image processing, which I kind of expected going in. That's part of why I took it, because I already have like a ton of experience in computer vision. Didn't really feel like rehashing that stuff all over again. In any case, yeah, we talked briefly about feature matching, some of the different algorithms like SIFT models and Harris methods. We used OpenCB's orb function in the kind of boilerplate that they gave me for the assignment, which I'll talk about in a moment. But yeah, we just use OpenCB's kind of feature matching thing. There's a little piece in there about, how many features do you search for versus how many of them do you need to match to actually do the merge. A little bit of like hyperparameter tuning there, which was interesting, but for the most part, I think the feature matching was less the focus of the assignment than the warping stuff. Speaking of which, we learned about the kind of different image transformations you might do, like translational, rotational, affine, where you're like shifting the shape, like you're changing the shape as you move it, right? All these different types of image warping / morphing, however you want to call it. And yeah, I kind of use them based on the homography matrix, which is kind of like a feature map generated by, these kind of methods that I just discussed. You use that map to kind of warp one image such that its features line up with the other one. And you're kind of doing that iteratively from left to right. So, that like warping side was a little bit more what we focused on and was pretty challenging and interesting. I mean, I would say like this assignment was pretty cool. It was pretty difficult for reasons I'll discuss shortly. At first, I actually found the like second assignment to be more difficult, but then pretty quickly that inverted, and this one really got to be difficult. I struggled with a little bit, but by the end, I'm really confident in how I did. I got good results in the autograder, and yeah, I think I learned a lot, which is cool. So a couple of things to note, right? For one, it does seem like there's actually a pretty good progression of topics from one assignment to another to the next, right? So last assignment was on pyramid blending, and there were still kind of remnants of that, like image masking and Fourier transforms, like those kinds of things were still present in the panorama assignment, even if it was less of the focus. And it definitely appears to be relevant to the next assignment, which is about like object removal, which again, I'll talk about shortly. But yeah, it seems like there's really good continuity there, which I always appreciate. I think the AI techniques for robotics class did that really well. And the game AI class I took previously, less so. It felt more like a special topics class, which is okay. But I do like for some of the harder, more in-depth classes when there's good continuity. And that seems to be the case here for sure. Another lesson I kind of learned the hard way was they provided a bunch of boilerplate like functions, just like they did with the second assignment, and then said, oh, it's up to you to write your own blending method, right? Like that's your job. You got to go figure one out. I think they gave a very basic one, but you were not allowed to use it. And I don't even think it accomplished what we were trying to accomplish anyway. It was like a really basic, like basically just enough to check if your warping and your, drawing a blank. Oh, feature matching was working properly without actually making them look good. Like there were huge seams between them. But in any case, I took that as like, oh, I guess the boilerplate above is just kind of suggestions of what you might need to kind of point you in the right direction. That was the way I interpreted it. That was not the case because each of those like helper functions that is used in your blending method is tested by the autograder, right? So you're expected to have something in there that works and, you know, returns objects of the right sizes and obviously with the right values in them, right? And so I had to, like, I had an implementation that was all in the end function with no helpers. And the first time I submitted it, I got like a bunch of zeros for all the different helpers. Like, oh my God, that was very annoying, but it wasn't that big of a deal to just kind of lift and refactor my code out. And, you know, to be honest, fair play, because I should have used helper functions. I was just being lazy, so understandable there. But yeah, once I got that working, I got the autograder through. I think I missed like a couple of values. You get a statement that says like, oh, you know, you got the right sizes, but your values don't match. And I have actually heard like complaints on OMS Hub about like you have to be accurate to 10 to the 9th or something obscene to get credit for getting the right values, which that is a fair complaint. I mean, that's really aggravating, and it is kind of annoying to not see a perfect score. But I mean, I still got, I don't know, 30 out of 50 or 30 out of 40. And the last assignment I got like 47 out of 50 and a couple of things I got incorrect numbers and I didn't really care. So I just kind of left it. So we'll see, who knows? Hopefully they don't like wreck me because I think the autograder is kind of just a start to the grading process, which appears to be the case for a lot of these, right? I mean, the main goal of the autograder is to like test that your code runs and that you're returning things correctly. So the TAs can then go and do apples to apples comparisons. And so, you know, I get it. I think it's fine. I have a few complaints with this class, but the autograder isn't really one of them. Also, they have these like submission penalties. Like if you do it enough times or your files are too big, you get a penalty. The files too big thing is aggravating because I don't understand why they're so preoccupied with GradeScope's bottom line. I mean, maybe they have a budget and they're only allowed to use a certain amount of memory, but it's frustrating because like I have to use things like small PDF and resize my images a bunch of times, like reduce the resolution, and it's just kind of dumb and annoying and results in several submissions, which are also penalized. But you're able to do like I just saw the project, and you're able to do 30 submissions before you start losing points, which then kind of begs the question like, why bother even having a point deduction if it's such a high threshold? I don't know. Again, I have a few complaints about how this course is being run, but you know, this is not really keeping me up at night. So yeah, did the panorama image. Had to take a couple of images of my apartment, stitch them together. It was very challenging to get it right because I think, you know, first of all, there were a couple of like silent errors that were causing weird things like tunneling and I don't know how to describe it, but like my images would collapse and I'd get like a really tiny panorama and a very large black canvas. So there were a few silent errors I had to work through that weren't terrible, but it was kind of anxiety inducing, like take an image and then, you know, go try to stitch together. You get kind of garbage and it's like, is it something with the image? Is it something with my algorithm? Something with the hyperparameters and passing into the orb detector? Like there were a lot of things to debug kind of simultaneously. And yeah, it was a little frustrating in terms of getting my individual pictures to work. But once I kind of started to converge to something that was working more consistently, kind of closing that last 10% was pretty easy, I would say. but kind of the opposite of how I think things usually go, where like usually the first 90% is the easy part, and then the last 10% is the hard part. For this project, it actually kind of felt the opposite way, where like it's a slog through the beginning to get through everything, but then once you actually get something that's close to nominal, closing the gap is simple, right? So yeah, I think I'm gonna get a good grade. I haven't gotten grades yet back on anything, right? So I don't know. I could be, like I could have a 0 in the mailbox waiting for me, but hopefully not the case. Yeah, but still waiting on those grades, and I'm pretty optimistic. We'll see how the grading goes. I'm sure we'll get either a good video, which is just kind of like normal, what's the next assignment in the course, and just kind of talking about it. And oh, by the way, I got my grades, so you'll get one of those videos. Or you'll get a, holy shit, they grade like terribly in this class, and I'm annoyed, and I'm not doing well. So stay tuned for that. But yeah, really briefly on the next two things I'm kind of doing. I did peer feedback for assignment 2. No big deal. I don't actually think the rubrics that we fill out count towards the other student's grade. And so people are like pretty honest. I mean, overall, all my feedback's been good, but I've gotten a couple of actually good pointers. So, props to them on the peer feedback system. The only thing that's a little weird is like I get an email and it's a different site. Like it kind of feels like an extension to Canvas rather than a part of Canvas. So it's a little hard to navigate and keep track of, but at the end of the day, it takes like half an hour. I showed up to work like 30 minutes early at one point and just banged it out before my boss showed up, right? So yeah, not a big deal there. And then I have Notebook 2 coming up, which I don't quite know how the notebooks line up to the assignments. Like I don't know if Notebook 2 is specifically about pyramid blending, but I do remember like going through the notebook previously, and it was like somewhat relevant, more just kind of general to, Fourier transforms of images and stuff, rather than pyramid blending specifically. And so I would assume the notebook quiz is going to be similar to that. And so, yeah, I got to take that, I think, by like Tuesday. So, but the main event, some big game hunting, Project 1 is coming up. So that is due October 3rd, I believe. And it is currently September 18th. So I got a little bit of time, but, I have a lot going on for work, and I haven't gotten as much into it yet as I would like. So I'm not going to talk about it too much in this video, just because I'm sure it will get at least 1, maybe even 2 of its own, just pretty big. But effectively, we're given a paper describing an old school like method of object removal. So I know in the modern world, like a lot of times you do stuff on your iPhone or whatever. A lot of that actually uses deep learning methods, and those are incredibly interesting. But we're talking about a paper from like 2004. So it's really interesting, like, how would you describe it? It's called exemplar-based inpainting or something like that. And so, you're sampling from the known image, like the non-target region, and you're propagating that into the target region, which is kind of the area left behind by whatever object you're trying to remove, excuse me. So honestly, I really like this stuff, and this is part of why I took the computational photography class rather than computer vision or deep learning. Not that I won't take those classes, but just, one thing at a time. Reason is, like, I've done a lot of deep learning in my career for computer vision applications, but as an aerospace person, a lot of times the compute you have available to you is very limited. And so if you can get away with, not loading a neural network or something onto, the platform you're flying, then, you can save a lot of computational power and do a lot more with a lot less. And so, I kind of have this gap in my knowledge of like, oh, I've done a ton of stuff about convolutional neural networks and transformers and things like that. But, I've never implemented a Sobel filter before up until stuff like this class, or I had never even done linear regression. I mean, I obviously know what linear regression is, but I never had to, sit down and do an assignment on that stuff. And so kind of getting your reps in with the classical things is, I think, very valuable. So that's what I'm doing. So yeah, it's hard to imagine a world before, the deep learning era, but 2004 is definitely it. So yeah, I'll talk more about it in the next episode, but pretty excited about it, honestly, even though it's a lot of work. I'm a little worried because they kind of give you freedom in your implementation, but also they're very anal about OSI and what algorithm you use, but then you can't reference certain algorithms while doing certain algorithms. And they seem like simultaneously very nitpicky, but then also for the project expecting you to have a lot of autonomy and figure things on your own. And so, that's a little bit of conflicting messaging, but at the end of the day, the paper is the paper. I feel like I understand it pretty well at this point, and so I'm not going to diverge too much from it. the rest of it's not up to me, right? So I'm gonna do my best, and whatever happens, happens. So yeah, pretty excited, and stay tuned. So that was episode 26 of my GT OMSCS vlog. Like I said, I'm an aerospace engineer getting this degree at night while I continue to work full time. And yeah, if that's content you're interested in, or you're just interested in general like professional development content for young engineers like myself, then definitely like, comment, and subscribe to the channel. We're almost at 200. We're so close. So feel free to be the 200th sub, right? Yeah, thanks a lot for watching. Stay tuned, and I will see you next time.